Howard, nice to see you all again. We are going to talk to you about getting there, getting to space, being there, and then getting back, and how we, ways to limit the pain. What can we do? And so, with me on the stage, I have Kelvin Coleman, who is from the FAA Office of Commercial Space Transportation. We have Michael Lindsay from OneWeb, which is a rather well-known, very large constellation of very small satellites. And we have Phil Cunio from ExoAnalytics, which is like the largest commercial network of sensors and a really kickin' analytics company. And so I'm going to let each of our panelists tell you about what they do and their piece of this big puzzle. And then we've got some questions, and we're going to get into a nice informal discussion along the lines of what we did yesterday, if you were here for that, on another topic completely. And then we're going to open it up to you if, of course, the hook doesn't come and grab us first. And with no further ado, here's Kelvin. Thank you.
All right. Well, thank you, Diane. And yes. So first of all, I want to say thanks, Diane. Thanks, Chris. Thanks to the folks at the Space Frontier Foundation for the invitation to be here today and take part in this panel discussion. Unfortunately, I don't have any cool charts. I'm a government regulator, so I don't really have anything that cool to put up on the charts. I'll leave it to these guys. I think you guys have some charts. But at any rate, so this is a great discussion that we're having, getting there, being there, and getting back, and limiting the pain. In the Office of Commercial Space Transportation at the FAA, we have a twofold mission mandate. First of all, is public safety. Secondly, our job is to encourage, facilitate, and promote U.S. commercial space transportation. But by far, public safety is our #1 mission mandate. In order to get there, that requires licensing if you're a commercial entity from our office. In order to return, you also need a license from our office in order to do that. Also, in order to get there, you need to travel through the National Airspace System. And also the same for coming back. I need to travel through the National Airspace System to come back. So those two things I'm going to touch on here briefly in my time. The licensing effort and the traversing through the National Airspace System piece. When it comes to the licensing piece, since 1989, when we had our first commercial launch, we've had over 300 successful commercial launches in the United States. And by successful, what I mean by that is we've had none that have resulted in a public injury or casualty or significant property damage. That's how we measure our success in terms of protecting the public. Great safety record. We've done that largely in collaboration with our industry, and a lot of credit goes to the industry when it comes to public safety. There's a great focus on that from our industry stakeholders, as well as we put a lot of hard work in from the government side as well. Of course, over several years, several decades, the rules that we've had in place have, in some cases, become outdated. When we first began this, we had expendable launch vehicles, and in some cases, not a few cases, reusable launch vehicles, but most expendable launch vehicles. And the rules that we promulgated were really based on Air Force and DoD standards, things such as that. As we've seen the industry evolve over recent years, it became quite apparent that the rules that we had in place, while we've been able to ensure public safety, those rules needed some overhauling. And so with the emergence of the National Space Council and the work that they've done to put forward a number of space policy directives, namely Space Policy Directive 2, which was focused on overhauling the regulatory construct for commercial space transportation and commercial space in general, we were asked to go back and take a look at our regulations and to do some work to streamline our regulations, make them more innovation-friendly, if you will, while maintaining public safety. And we've begun that effort, which is currently underway. A pretty significant undertaking, if I might mention. Essentially, the current regulations are separated into different parts. If you're an expendable launch vehicle, well, that's one part. If it's a reusable launch vehicle, you have a different part. If it's a reentry vehicle, yet a different part. If it's reusable, yet another part, et cetera. So what part of the effort is to consolidate those different parts into a single part, and also move away from what I will admit are pretty prescriptive regulations right now to a more performance-based rulemaking construct. We're trying to do things to make things simpler, which will, such as allowing a single license to address multiple launches from multiple locations. Right now, if you're going to do launches from different locations, well, that requires different licenses. And some of you may recall Gwen Shotwell from SpaceX mentioning during her testimony to the National Space Council that it required heroics to go from pad 39A, which is at Kennedy, to pad 40, which is right down the road at Cape Canaveral. And the heroics she was talking about really was the licensing process, being quite cumbersome, having to go through that when you just want to go down the street, as it were, to launch your vehicle. So the new rulemaking will fix some of that. And so we've been undertaking this rulemaking effort. And by the way, it takes typically about 4 to 5 years to do a rule. We had a pretty aggressive mandate in front of us to really move this out in 1 year. We were able to get the rule published a little over 1 year, if you will, on April the 15th of this year. The rule is out for comment now. And, I want to say a little bit about our attitude about it. I mean, rulemaking is tough. It's hard. It's not easy. Certainly a rulemaking of this size. We certainly went into it with the idea to take in as much industry input as possible, as we had time to do, which we did. And we gave it our best shot, if you will, in terms of drafting rules that we think will meet the needs of the industry, that are streamlined, performance-based. Did we get it all right? Probably not, and we're hearing about that right now. That's what the comment period is all about. And so we have a comment period that is now underway that we've been engaged in since the 15th. We've extended that comment period on one occasion before, and we are about to extend it again for an additional 20 days out to August the 19th of 2019. So that'll take us for a total of about 123 days, we think, of public comment period. And again, this is the time in which the FAA is in listening mode to hear what we didn't get right, how we can do it better, how can we fix it, and that's what we're hearing from the industry on right now. There's been discussion about the possibility of having a public meeting. And we think that the current process that we have in place is probably the process that will serve us all the best. And so again, our doors and our ears are open right now during the public comment period to hear, again, what did we get wrong, what can we improve on, et cetera. So we're looking forward and we're eager to hear those comments back from the industry as we move forward. Once the comment period is over, that's not the end of it. We still have some work to do to go back and work on finalizing the rule, and there may be additional opportunities to engage industry along the way as well. So we'll see how that goes. But still a long way to go in that regard to get that right. Our end game is not simply to put out a rule to get to the end. We want to put out a rule that is in the best interest of the industry, best interest of our government stakeholders as well. So we're working hard on that. Next, I want to mention a little bit about NASS Integration, National Airspace System, the NASS Integration. This is an issue that we've been working on for quite some time in the FAA. Going back, I've been in the agency for about 20 years now. When I first came in, this was an issue. Back in those days, it was, launches out of the Cape Canaveral, Florida, and where, if you're a commercial operator, the issue was, if you're commercial, or if you're NASA or if you're DOD, we all wave the flag and we say great. If you're the airlines, if you're a commercial entity, well, it's a little different because everyone's competing for the airspace, and if you're a commercial entity competing with a commercial airliner, well, there's competition there involved for that airspace. And so we've been working this issue for quite some time. We've made some good progress, though. In the last few years, as we've seen the launch rates increase, last year we had about more than 30 launches. This year we expect to see more than 40 launches. And next year we'll see more than 50 launches in the U.S., which is a great progress by the industry in that regard. But with that comes concerns about how do we accommodate these launches while we see commercial aviation on the increase and rise as well. And so we've been hard at work with our partners in the agency as well as the industry to come up with tools and processes that will enable us to move forward and to accommodate all NASS users, commercial space transportation included. We have a tool that we've been able to prototype called the Space Data Integrator. And what this tool essentially allows us to do is have better understanding of the vehicle's health, where the vehicle is in the airspace, which enables us to be less conservative when it comes to allocation of the airspace around that launch vehicle, which we think will benefit not only commercial space transportation, but the commercial air carriers as well, who are very concerned with the number of launches that are taking place. We're also working on additional tools, something called HRAM, which is called Hazard Risk Area Management Tool, which will allow us to predict or understand in real time if there's a vehicle breakup where that debris is, so we can allocate aerospace more efficiently in real time around that particular mishap. So those are a couple of tools that we have in the mix. We're working very closely with our air traffic organization that has the lead in this area, if you will, for NASS Integration, and they're a great partner with us, and we're making significant progress. So those are a couple of things that we're doing in the FAA right now to try to limit the pain, if you will, but a lot of work to be done still, and we look forward to working with our industry stakeholders and partners to carve out useful solutions as we move forward. So that's it.
Thank you. Michael.
Sorry. Well, yeah, thank you for having me here. It's a great honor to be part of this panel. So I first want to talk about what OneWeb is doing. OneWeb is the company that I work for. I want to talk about our mission, why we are launching our satellites, and then talk about what this means for the space environment and things like space traffic management, SSA, et cetera. So I have some slides to get through. OK, here we go. So first I want to talk about our mission, but I actually have a short video, it's about a minute long, that talks about why we are doing what we're doing, which is, of course, launching a constellation of several hundred satellites to provide global broadband internet access to any part of the world. This is a great need right now, and our mission is to help bridge the digital divide. So this is a short video that kind of touches upon this subject. Half the world is unconnected. The tendency is to think, wow, the unconnected must be really missing out. But the connected are missing out just as much. What types of culture, traditions, knowledge, and talent is the rest of the world missing out on? OneWeb's mission is to connect all the unconnected schools in the world, and there are many. The reason why we are here in Caracola is because it is so remote and so difficult to get to. Satellite internet is essential if we're going to be connected. So this footage was actually from a trip that I took earlier this year to Nepal. I was able to hike to a remote school that has no internet connectivity and teach them about satellites. But they're also one of 6 schools that we will be connecting and providing free service to. So it's a mission that we're very passionate about. It's providing this connectivity to areas that do not have the infrastructure currently to support this. So this is the mission that drives us. And to do this, to accomplish what we're setting out to do, it requires hundreds and thousands, if not thousands, of satellites to cover every part of the world. So that is what OneWeb is doing. And just to go over a little bit about the OneWeb timeline so far, actually this past Sunday was a 5-year anniversary for us. I've been there since day one, so it's been a real fun journey. I include a couple of fun pictures there that are from when we were building satellite mock-ups in our founder's garage, actually. But since that time, we've raised over $3 billion in funding. Just this February, we launched our first 6 satellites, and these satellites are functioning beautifully. Just last week, we demonstrated 400 megabits per second speed with 30 milliseconds ping. So the system's it's working great. And later this year, we're going to start launching 30 to 36 satellites at a time. And we'll turn on initial coverage when we're over about 600 satellites. So that's our mission. But what I also want to mention is that just last month, we launched a campaign that we're calling Responsible Space. Because obviously, we are launching a large number of satellites. We need to be very mindful about the space that we're occupying and what we're doing in terms of activities. We always want to have a mind set towards sustainability and protecting the environment. So what is responsible space? Since day one, we've been very strongly dedicated to the notion that space is a shared natural resource that should be available to any and all to use. And if it's used responsibly, this is a very powerful asset that we have. It's critical in our daily lives. And so it's worth protecting. We really need to focus on the sustainability of this environment. So responsible space is the practices and operations that we use, the designs, to make sure that we're, again, mindful of the potential impacts of utilizing space. And the whole goal is to minimize the potential for harm to the environment and also build a set of operations, norms of behavior that is also conducive to other actors and all types of applications in the industry. We don't want to prohibit any new actors or missions. This is a very wordy slide. I'm just going to cover the bolded colored points here. But if you want, you can read everything. So our responsible space campaign really boils down to three main points. The first one is responsible design and operations. That's, again, how do we design our satellites to be reliable, maneuverable? How do we design our operations to make sure that we get satellites there, we operate safely, and we bring them back in a timely manner such that we're not just leaving space junk for 25 years or more in space. And how do we design the constellation itself, the actual orbits of the satellites, to be minimal risk? The second point is developing a space ecosystem. A lot of times we see regulations as constraints and additional costs to the commercial sector for compliance. And that it can be a barrier and it can slow progress. But if you also sort of develop an ecosystem that supports and promotes sustainable behaviors and even create new business opportunities out of sustainability, then it becomes much more attractive and you have a much longer term solution that everyone can get behind and take part. So we believe that's very important, not to just have the regulations and behaviors, but to have an industry and ecosystem behind that. And then finally, there's supporting policy outcomes through collaboration. We want to engage with other operators, other administrations, organizations to come up with policies and promote policies that support sustainability. Ultimately, if one company or operator is doing something that they think is responsible, it doesn't really have an impact. It's not effective if all the other operators are operating with the same amount of responsibility and awareness. Everybody has to be on the same page and collaborating in a way that, again, is conducive to sustainability. So a little bit more about responsible design and operations. This is what OneWeb views as things we should take into consideration is what we're doing. For responsible deployment, it's making sure our satellites are very strongly qualified and tested on the ground. We're not launching up something with a high chance of failure on orbit, because again, once it fails in orbit, it becomes everybody else's problem, and we don't view that as acceptable. We also launch and operate in orbits that launch into and operate in orbits that have a low density of resident objects in there. We're talking about termed lethal non-trackables, for example, or trackable debris. We want to avoid congested orbits to make sure that we're minimizing risk. Responsible operations, of course, we always know where our satellites are to a high degree of accuracy, and we have a high level of maneuverability to make sure we're avoiding other operators, debris, etc. But what's also very important about that is that we communicate our plans. We work together with other operators. We tell them where we are going. We hope in turn they tell us where they're going to go, so we can make sure that we have the best set of SSA, space situational awareness, to make sure we're making well-informed decisions and choosing trajectories and orbits that are safe. And then, of course, there's responsible disposal. We have a high degree of reliability on our system that allows us to deorbit. And we aim to deorbit our satellites in less than 5 years. Just get them out of orbit, get them out of the operational and congested orbits to make sure that we're not leaving trash up there. And this is very important to us. And then we have, well, I'll talk about it on the next slide, actually. So for developing the space ecosystem, again, we're exploring new technologies for fault detection, anomaly resolution, because we're going to have a very large data set of satellites that are in orbit. So we'll be able to characterize what's going on with our system. And again, that sort of data collection also fosters potentially new opportunities. But one of the key things here that I'm actually pretty proud about is the development and standardization of in-orbit capture interfaces. So yes, we designed very reliable satellites, but we had to come to terms with the fact that at some point there could be a failure on orbit, and we could have a satellite that's unresponsive and unable to bring itself down. So to address that scenario, we decided to put a sort of grapple fixture interface on our satellites. This can be addressed by a third-party satellite, and that satellite can mate with our satellite and grab it and tug it out of orbit, even when our satellite is non-responsive and non-cooperative. And we want to make this interface completely public, so other companies that are looking into ADR, active debris removal technologies, can look at our interface and design around those constraints. And again, that's how we're trying to foster this ecosystem, create business cases, and try to lower the cost of entry for ADR-type services. And of course, the supporting policy outcomes through collaboration. That's kind of in line with what I'm doing right here today. OneWeb has been very active in participating in these discussions. We want to engage with as many people as possible. We've been doing this for years. I can remember before we were even a year old, we went to, it was JSPOC at the time, but effectively 18th Space Wing, and talked to them about our plans to let them know ahead of time what we were going to be doing and develop that relationship so we could kind of identify early bottlenecks and talk about what are the changes we might need to see in how the system operates in terms of the larger system. And then what we think is responsible norms of behavior, we also try to communicate those. And we're not trying to say we know what's best. Part of the reason of being open, or part of the benefit of being open and transparent, is that you are also open to criticism, and others can give you feedback about what is maybe not the best idea or how things can be changed. Maybe what's best for us isn't best for another operator. So through communication, collaboration, we can come up with policies that, again, are sustainable but also conducive to a healthy ecosystem of multiple applications, competition, et cetera. So that's all I have. If you're interested in looking into more about our Responsible Space campaign, there's a website, responsible.space. So thank you.
Good afternoon. Looks like I might be the one who gets to talk about the pain. So I work at ExoAnalytics. We do a lot of space situational awareness. That's pretty closely connected with space traffic management, which I think is the common thread bringing us up here. How do you deal with what's on orbit? We already know it's supposed to do good stuff. What are the things it might do that we don't quite expect? The way the company works, we have a large network of sensors all around the globe. So we have somewhat over 300 sensors, telescopes pointed up at the sky right now. We mostly watch things that are in geosynchronous orbit, so they're pretty high up. They're nice and stable in the sky, but we watch all of them, pretty much all of them, every single night, as long as the sun's not blinding us. So we have a lot of data. We have a lot of ideas of what's happening in space. We have some pretty good ideas about what might be happening, what kind of shenanigans might occur in space traffic, especially at higher altitudes. And I will note that we collect a ton of data in the process. And when I talk about space traffic management, I'll take a small diversion here, and I'll talk about what I think this might entail. So what you see here is a little video of some satellites maneuvering. You see two of them actually crossing each other, and then they uncross. Well, unless you know exactly which one is which, it's a little hard to tell if A and B came close together and went back apart the ways they came from, or if they actually crossed over each other. And that could be confusing later if you have the same person trying to send the commands to both of them. You could actually have a situation where you tell one of them to go forward, and you think it's the one in front, but if it's the one in behind, you tell it to go forward, you now have a problem. Anyway, if you keep watching everything all the time, you start to get an idea what the patterns of life are for these. And because of all the sensors we have a lot of ideas about what the patterns of life should look like and what kind of things you might want to look for if you were doing space traffic management. So the way I think about it, and I'll just do this briefly, the way I tend to think about it is an orbital slot. There's a little space. In geosynchronous orbit, it's actually a pretty clear spot hanging over one longitude. In lower Earth orbit, it might be sort of a box that moves along a little ring. But when you look at this, there's a satellite in the middle of this. That's where you're supposed to be. And then you have a sensor, and you can see an observation. Cool, it's where it should be. Look again, maybe it's not. Maybe a little off this time. Things drift inside their boxes, and over time you can see patterns forming. And if it turns out that all this pattern is somewhere inside that box, you're in pretty good shape. If it's not, if it's a little bit outside the box, then maybe you're not performing as well as you could be, and maybe you even have an indication of a satellite that may experience a problem in the future and become some kind of an obstacle. And the more you have on orbit, the higher your chances are that one of them will possibly, have some problems and maybe be an issue for others. Anyway, so we see things on orbit. This is a geosynchronous satellite, and what you're seeing is, if this works, this is a video from, yes, that is, oh, that didn't work. Could you click on the video for me, please? See if it starts to run. Thank you, sir. So what you see there is the satellite AMC-9 holding orbit. It's getting dimmer and brighter. What that actually means is it's most likely doing something like spinning in place. Oh, look, little dots are coming off it. That's not supposed to happen. So you can see them dispersing in all directions too, including one really big one. We did a lot of analysis on this. What we think happened is something went wrong. The people who own the satellite tried to fix it, and this is our best guess. We don't have any official confirmation, but it looked like the satellite was spinning, and then at some point something went wrong in the way they were trying to reduce the spin, and pieces started separating in all directions. There's a lot more work on this that we have published in other places. I won't go into it here, but basically weird things happen on orbit. Okay, one weird thing happened. If you could click this video again too, please, sir. Thank you. Oh, look, next month it happened again. These are my two favorite videos because we have the most analysis on them. We have the most depth of analysis on them. But what you see here is, in the lower left, is actually that satellite I mentioned called Telcom. And what you see is it doing something it's not supposed to do. There you go. Those are neighboring satellites. What you see is pieces coming off, mostly in one direction, and a spray of, from our point of view, it's little photons on a screen, but it's apparently a spray of something coming off in one direction. That one's very interesting. When you go back and look at it, it turns out that it was actually maneuvering at the time. Best guess is something on it just kind of popped and stuff sprayed in one direction. Again, a lot more analysis on this, but suffice it to say, interesting things do happen on orbit. And we've been looking at geosynchronous orbit, which is really high up. Without going into all the depth of what's on this slide, we did some early analysis on what it would look like if you were looking at a LEO, low Earth orbit traffic regime. Well, it's a little different. Your density of objects is different. The time you have to get observations on them is different. So if something's in geo orbit, you have eyes on it pretty much all the day throughout most of its orbit. If something's in LEO, you have one sensor. Basically, it zips overhead. You see a small fraction of its orbit, and what happens to it in the rest of that orbit, you don't really have a lot of ideas about. So you have different analyses you have to do to predict what might happen to it. And because you have fewer sensors, your timelines are different, and your command and control timelines are very different. So, long story short, if you wanted to do good space traffic management on a LEO constellation, or a lot of things in LEO, you would probably need to automate as many chunks of it as you could. You want these satellites to talk to each other, or to talk to a central station, and basically do some level of avoiding each other without keeping humans in the loop. Because especially if you had thousands of them, you would have a lot of humans having to pay a lot of attention. The scale of the problem would make air traffic control look pretty interesting. Again, kind of early. Another interesting issue, so I already talked about how much data we collect. I ballparked it at about 11 terabytes per day. That's raw imagery collect, data we can use somewhere or other. We absolutely do not use that every single moment. We're not cramming 11 terabytes through every single wire to all of our systems at all times. We have an architecture in place specifically to manage that, data depth on demand. So you get something that you extracted from all that data, and it tells you, is this normal or not normal? If normal, great. If not normal, pull down some more data. That's a lot more depth information. Is that normal? Okay, sure, fine. Just something weird that showed up in the little bit you got earlier. Not normal? Okay, time to get even a lot more data and figure out what's really going on here. So all this data you collect is a huge amount, but the data that actually points to something is going wrong and you should deal with it right now, usually that's the amount of a few kilobytes of data per day. And if you can get that to someone, then they can do something about it right away, again, without overwhelming a whole bunch of humans who have to do this kind of traffic management thing. In general, it's a lot of data. And if you start to launch super constellations or mega constellations, whatever you might call them, what you're going to end up with is that your amount of data sources on orbit might double at a minimum, is my guess, depending on how many of the mega constellations fly and on what time scale. And you're going to need a lot more data to handle the potentially more higher number of conjunctions that might occur, as well as some of the issues come along with having the same people flying the same satellites along the same sort of tracks. It'll be a very interesting problem. In general, you're going to find it a problem to deal with that kind of thing. Shipping all that data through your network is going to be a challenge. The infrastructure to ship data from your sensors around the world to your command and control points probably does not exist, and you would strain it if it did exist. So again, another challenge. This video may or may not play. This is just a thing I'll put on for a second. It's a view of some of the observations we collected over the course of a year. But in general, all I wanted to do was tell you how we tend to think about space traffic management, how I think about it at least, and some of the interesting issues that crop up, things going wrong. We need to deal with a lot of data, need to manage a lot of satellites, hopefully in a really, with a near real-time capability. So that's what I have.
Thank you. Okay, so can you hear me? Is this, yeah? Okay. So we got a good overview, I think. I think we have come to understand that there's a lot of stuff in orbit that can create a lot of problems, that there are a number of different orbits. Phil spoke a great deal about the GEO and not as much about the LEO until the very end. And OneWeb you're going to be a LEO constellation.
We are a Leo.
You are a LEO, exactly. You are a LEO constellation. But I have a question about why you've chosen the orbit that you have, because I know that some of the other mega constellation people like SpaceX and Amazon are moving to lower orbits, and yet you are staying at 1,200 kilometers. And I wondered if you could explain the rationale for that to us.
Yeah, that's a great question. And I sort of hit upon this earlier. The orbit selection was very intentional. We looked at the debris population. Where are there high amounts of high-risk debris? And that's actually, if you've seen the peak of the plot, there's peaks around 800, 900 kilometers. And around that peak, it decreases, but there's actually a nice little minimum point around 1,200 kilometers. That debris population also decreases as you go to lower altitudes. But no worries. The problem with that, when you go to lower altitudes, is that to provide the same amount of coverage, you need more satellites. Because you're closer to the surface of Earth, you need to have more satellites overhead to provide the same amount of coverage to your users. So looking at altitude alone is not necessarily the right metric for what can be deemed responsible. There's a number of satellites, there's the debris population. At lower altitudes, there's actually still higher amounts of debris than at 1,200 kilometers. And when you were operating a large constellation of these numbers for the first time, we thought it was the most responsible thing to do was to make the job easier, to take smaller amounts of risk with our first take at this and operate in a regime that where we don't need many satellites, and we know there's going to be fewer potential collisions.
Well, you also mentioned during your talk about the role of collaboration in putting together norms, and certainly that's something we're all looking for ways to do that. So I would like to throw this question out to all three of you. When you're thinking about stakeholders in the space situational awareness, the data, the capabilities that already exist and those that are emerging, and when we think about the kinds of analytics that can be developed and the kinds of behaviors that you yourself are practicing and that we would all perhaps like to see practiced, who do you consider those stakeholders to be? And do you think that we're engaging with all of them? So you can start.
Well, certainly there's stakeholders on the government side as well as the industry side. I mean, certainly this is a question I think that the National Space Council took up in formulating Space Policy Directive 3, Space Traffic Management. The idea there was a sort of a whole of government approach with the DoD, Department of Transportation, Department of Commerce, NASA, all those players involved. And as a matter of fact, the implementation plan that's currently in place has all of those players coming together to figure out best practices and ways to move ahead on space traffic management. So those are some of the players, companies like ExoAnalytics and others that have some of the capabilities that we just have seen demonstrated, obviously are players in, and then also the companies with the capabilities that were just laid out by OneWeb, SpaceX and others have some capabilities that they're working on as well. So I think there are a lot of ideas out there that are coming together. I think it's going to be a community that will have to figure out the best ways ahead. And we can't forget, of course, our friends on the Hill as well, Congress. So they need to be invested in this challenge and this problem as well. And then there's the international community as well. So because it's an international issue, I think. And so we have to bring all those players together and kind of get this figured out.
Anything to add? Are you speaking to any of your colleagues in the satellite operator world? I mean, you said that you've gone out and done a lot of outreach, but tell us some of what you're doing, because I really think you have a message, and I think that message it's a beautiful message. And here we are in a room of people that are innovating. You know, the idea of including responsible behavior in your business plan is not a new idea, but certainly one that bears mention.
Yeah, absolutely. And we're taking part in a couple groups of industry associations. There's been a couple different groups of operators who have come together to come to a common understanding of what they think should be responsible norms. And that's a really powerful tool because anytime you come to regulators with an idea, you have a much higher chance of success in getting this in place if you have a coalition of operators who all agree on the same thing, because you want to make sure you're not doing anything that is anti-competitive or puts up barriers. So when you have these industry associations, that's a much stronger voice. So we've been very much engaged with these groups. Of course, there might be a drawback, and that's when you have a very large group. The larger your group, the more difficult it is to reach consensus. I think the extreme case of that might be the UN COPIUS, which is the top tier international body that looks at uses of outer space, and getting every country to agree to hard guidelines and regulations is a very lengthy and difficult process.
Even soft ones.
Yeah. Yeah.
And I would love to hear from you as well, Phil. And also, I think perhaps you could address what the role of the cloud computing community might be in some of this.
Okay, so I would think about this less in terms of specific stakeholders, and I would actually reach for an analogy to existing maybe industries or fields of enterprise. So if you imagine that space is a natural resource that the public has some stake in, which I think is an accurate assessment, I would certainly concur with that. Then you have some people who regulate it, and you have some people who build infrastructure in there. You have people who support that, and you have people, maybe several layers, and you have users, and many layers of users, and at the bottom of it you'd find the public, which has some level of stake in all of it. So to push that a little bit, maybe Mr. Coleman is kind of, I would analogize what he's up to the people who lay out the rights of way along public land, and then Mr. Lindsay's company is the folks who put roads through there. And what we would be is the people who sell them surveying so they can put roads in the way they want them to go. And then you'd have people who use those roads to deliver your favorite things. And those are all different layers of stakeholders down there. But what you're doing is you're making various levels of use and you're building value on top of invested value in a really big way on top of an existing infrastructural system. And I think that's what's slowly growing in terms of space and managing it all. Space traffic management is currently the best term we have for how we explain how we want to guide that growth. And there's thoughts coming from multiple levels of the stakeholder chain, which is probably a very good thing. If you wanted to ask where the cloud computing folks fit in, I'd say they're down at somewhere first or second level service. So you have a bunch of links, communications links on orbits. Well, that's great. Maybe you can make your cloud communication be 10% more efficient. And that means you can now sell your services for 20% less cost, which means more people can use them, et cetera, et cetera. It starts to be a good thing. And again, you're building on existing infrastructure. So that's the way I would try to think about it. There's probably a lot more to go into there, but that's what I would say.
So I have a question for you, Kelvin. You were telling us about the Space Data Integrator, which is something that I've been kind of following for a number of years. And I know that you know, you kind of told me before it kind of is a whole. And I would like to know if you foresee that this Space Data Integrator, which is helping with the national airspace, how that's going to operate above Flight Line 600, if it will, because that's unclassified airspace here in the US, and yet that's still airspace we traverse to get to orbit. Yeah. And if there's a handoff that you contemplate, or what's in the plan?
Yeah, so you asked about flight line 600, flight level 600, which is, some would argue or debate or maybe say is the top of the national airspace system. So from ground to flight level 600, that's the national airspace system. Although, as you mentioned, there are flights that are above that. So when we look at the Space Data Integrator, it's a tool that's really intended to operate within, from ground level up to flight level 600. So it's really not designed to work beyond flight level 600. But how do we integrate, vehicles, what's the handoff when vehicles come back from space? And so right now for launch and reentry it's the same. And so what we have in place today is we have tools that we leverage. When I say we, I mean the FAA, the Air Traffic Organization, has tools that it leverages, such as temporary flight restrictions, where it creates airspace or it segregates airspace that allows launch vehicles to traverse through that airspace on launch, and also if there's a returning vehicle like a Dragon coming back, Dragon vehicle, Dragon capsule coming back, there's a segregation of airspace as well to accommodate that reentry back into the national airspace system. So today what we're doing is, as I told you before in a sort of crude way, we're making a hole in the airspace to accommodate these launch activities and reentry activities. However, going forward, we know as we see these operations, their numbers increase, there's question as to how sustainable that will be in the long run. And so we're looking at tools like Space Data Integrator and other approaches that will help us minimize the amount of airspace that's required for integrating these activities into the national airspace system.
Well, thank you. I think we got a very good overview of the different buckets of issues surrounding SSA and STM, and we'd like to open the floor up to questions. So I think there's a mic that's running around. Why don't we can start with Mr. Faust.
Kelvin, can you just talk about the process with the NPRM once the public comment period closes in August? What happens between the time the public comment period closes and you finally create that final rule? And it sounds like there might be more opportunity for industry to weigh in at some point from what you were saying.
Well, we're always going to be open to the industry's voice on this. I mean, of course, as you know, Jeff, there's been a lot of asking, if you will, for a public meeting and things such as that. And the point that I wanted to make, that I was attempting to make earlier, was that the FAA's ears are open to industry. We believe that the comment period is the right mechanism to hear what industry thinks about the rule. There's opportunity to ask clarifying questions during the comment period. We're responding to those. And of course, what we're obligated to do once the comment period closes is to, first of all, disposition all those comments. And so if we accept the comment, then great. If we don't accept it, then we need to explain why we didn't accept the comment. And that'll be made public as well. That'll be a part of the docket. And of course, then there's the process of going forward to finalize the rule. Again, there's a lot of voices. There are a lot of voices out there right now that would like for more intimate engagement, if you will, with the FAA. And again, we think that the comment period allows, this is an opportunity for us to sit back and hear and listen to what the industry thinks about the rule. Do we think we have a perfect rule? By no means we think that at all. We know that there's room for improvement, and we want to understand how can we go about to improve that rule, and we're looking for that input. And so at the end of the day, as a federal regulator, we're going to go back, and once all the comments are collected and all those comments have been dispositioned, we will draft a final rule that will hopefully address all of the industry and the stakeholders' concerns and needs.
Hi, I'm Tarun and I'm a student with SETS. And this question is directed to Mike. First of all, it's actually fantastic to see that you guys are working on the responsible space and you have some guidelines set so that you can go about doing things in a certain order. But since you guys have like over 600 satellites that you are sending up to space in different timelines, what exactly is the lifespan of each of those satellites that you're sending up there, and what kind of redundancies do you have in a way that if one or two satellites go down, does it affect the entire system, or are you just talking about isolating each of these satellites as an independent satellite and not a part of a whole constellation? So what exactly is going on with that?
To address your first question, the lifetime of our satellites is about 5 to 7 years. And then once they reach end of life, we'll decommission them, bring them back down so they can safely disintegrate in the atmosphere and completely burn up so that there's little to nothing that comes back down. In terms of redundancy, we have lots of redundancy in our system. And what's interesting is that our deorbit system is actually the highest reliability system on the spacecraft. So if other parts of it fail and it becomes a satellite that's no longer, let's say, able to provide its mission, provide service, we expect other components to fail before the deorbit system does. So we'll still be able to bring that satellite down, and that was very important for our design. And in terms of if there are satellite failures, an interesting feature of our constellation is that we have multiple planes, and we made sure that the crossing points of each of those planes would be at different altitudes. So each plane occupies its own little slice of altitude. So when you have a potential case where there's two satellites in different orbits, and they're both not controlled, there's going to be very little to no risk that they're actually going to run into each other, especially before we'll be able to take them out of orbit. So that's definitely a consideration that we've been made in our design.
Do you have something to say?
Yeah, I just wanted to jump in and ask. So, highest reliability, good plan. Can you quote any numbers on what you think the reliability for that is actually going to be? And what that maybe equates to in terms of like failures per year or number of satellites where you're likely to get a failure?
I think that number's public, but I'm not sure. I'm not
Fair enough.
Quote it right here. But.
I think we have time for one more question. If I'm not, I'm going to give us the hook because I'm being mindful of the fact that they're getting ready for the last panel of the day. So do we have one more? Can the microphone go to one of these people?
Right, in front of you.
Oh, you got it. Yeah, sorry. I'm blinded by the light.
The hole, how big is it and how long does it stay there?
It depends. I guess the question's for me. I talk about the whole.
Yeah.
Okay. It depends. We do analysis to determine what the aircraft hazard area is. And basically, it's determining separation standards on a case-by-case basis. So it depends on the vehicle type. For example, the aircraft hazard for a Falcon Heavy would be significantly different than it is for a smaller vehicle, like a Rocket Lab vehicle, for example. So how long does it stay in place? Again, it depends, it varies as well. What we're trying to do is not have it stay in place for any longer than it needs to be in place. And so we're trying to work on ways to release that airspace once that vehicle clears and is safely off on launch. Release that airspace as soon as we can. So there's no set time, specific time, but again, it varies depending on the vehicle operation.
Well, maybe we have one more question? No? Well, thank you very much. Thank you, panel.